Hello. Am I audible?
Good evening, sir.
Good evening.
Good evening, sir.
So in last class, we had just completed excess pressure or pressure difference between bubble or draw. So do you have any doubt from last class? Asma,
Yes, sir.
any doubt?
No, sir.
Okay. Next, related to surface tension or adhesive force or cohesive force, there is a term called capillarity. Suppose if you place liquid in a capillary tube, in first capillary tube, if you place liquid as water, so meniscus of it will behave like this. As water having smaller surface tension, so it will have greater adhesive force as compared to cohesive. So the particle of it will tend to attract with its surrounding molecule or surrounding capillary tube particle. So it will acquire this much amount of shape. So in this part, adhesive force is greater as compared to cohesive force. So theta, that is angle of contact, will be Q, and surface tension will be small, due to which particle of water will tend to attract with its surrounding particle, and hence it will tend to rise up. So level of liquid will rise in this condition. Next, in second tube, suppose if you place rose water, so it may acquire this type of meniscus. It means adhesive force equals to cohesive force, and theta is just 90 degree. So there is no rise or fall in level of liquid, so that its surface remains flat. In third part, if you place mercury, it may acquire this type of meniscus. In which cohesive force is much stronger as compared to adhesive. So theta, that is angle of contact for this type, will be obtuse. Surface tension of this liquid is large, and hence level of liquid will fall down. So capillarity is when you place liquid in a particular capillary tube or very thin tube. So depending upon its interaction with its surrounding particle, it may acquire these three different shapes. So the level of liquid may rise or may fall down. This phenomena is called capillarity. Is it clear?
Yes, sir.
So capillarity is the rise or fall in level of liquid in capillary tube due to its interaction with surrounding particle of tube. is called capillarity. So in first part, I have taken water so that shape of this meniscus is concave. In second part, rose water, shape of meniscus is flat. In third part, mercury, and shape of meniscus is convex. Just write it down till this point. We have to
Yes, sir.
calculate amount of liquid rise or fall, or to define some mathematical formula to calculate it. You all have written?
Yes, sir.
Yes, sir.
Asma, any doubt?
No, sir, no doubt.
You have written to this?
Yes, sir.
Okay. So we have to basically calculate amount of rise or fall in level of liquid in these three different conditions.
So could you scroll a bit up?
Okay.
Done, sir.
Okay. So Fan, you may take a screenshot.
No, sir.
So we have to calculate rise or fall in level of liquid. So first is ASIN formula. Consider capillary tube in which liquid may acquire this type of meniscus. So if you draw this particular curve to form complete circle, so it may acquire this type of sphere. Let's say radius of this particular spherical assumed diagram is R. There is interface at this liquid and this air. So we can draw a surface tension tangential to it. So the angle of contact at this point will be theta. Next, take a vertical line from this point to the center of this capillary tube and draw. So this horizontal line from this edge to its center will be the radius of this capillary tube. And if this is theta, so this must be 90 minus theta. So this angle will be theta. Is it clear to all of you till this part?
Yes, sir.
Initially, liquid was up to this point. I've just extended that particular curve to form a complete sphere so that we can assume this is a small part of that complete spherical bubble or drop, which having radius capital R, this tube having radius A. So if you draw a tangent to the interface of these two different medium, so the angle of contact at this point will be theta. If this is theta, so this must be 90 minus theta, so that this will be theta. So we have to calculate the relation between R and A from this part. So using this triangle, perpendicular, hypotenuse and base, we can write cos theta equals to base by hypotenuse. So R equals to A by cos theta. Next, we have to calculate at its central point, level of liquid is at this point, and its edge level of liquid is at this point. So there is some difference in height, which is called h. So this is the amount of rise in level of liquid due to its interaction with its surrounding particle. So we have to calculate this value of h. Okay. Asma, any doubt? Safan,
Yes, sir.
any doubt?
No, sir.
Okay. Consider a capillary tube having radius A, in which liquid having density rho and surface tension T is placed, which may acquire concave shape. So first is due to excess pressure. We can write Pi minus P naught equals to 2T by R, as this particular entire region is nothing but a spherical part. So we can write according to a formula, Pi minus P naught is 2T by R. Now we have to convert this particular capital R in terms of A, as A will be given. So it will be 2 times of T cos theta divided by A. Let's say this is equation first. And this pressure is due to surface tension. Again, we can write due to change in level of liquid, there will be a pressure that is called gauge pressure. So Pi minus P naught will be equals to rho GH. This is equation 2. Now in both equations, we have same term in left hand side. So from equation first and equation second, we can say rho GH equals to 2t cos theta divided by A. Now move rho and G to right side to get H. So it will be 2t cos theta divided by rho G A. So this is the required formula of calculation of level of liquid rise or fall due to its interaction. Is it clear? Samara, any doubt?
No, sir.
Now, depending upon value of theta or angle of contact, we may define three different conditions. First is if theta is greater than 0 degree, but less than 90 degree, means if theta is acute. So cos theta in this particular range will be positive. So H will be positive. So level of liquid will ascend. In second part, if theta is 90 degree, cos 90 is 0. So H will be 0. So there will be no change in level of liquid. So it will remain stationary or it will be remain in equilibrium. And third, if theta greater than 90 degree but less than 180 degree, means obtuse angle, cos theta will be negative. So H will be negative. It means it will descend. So depending upon the value of theta, we may find a rise of level of liquid or fall in level of liquid. Shravya, is it clear?
Yes, sir.
Okay, just write it down till this part.
No, sir.
Done, sir.
Done, sir.
Safan, done?
Done, sir.
Arslan? Asma, written? Now, related to this formula, there will be question to define mass of liquid raised related to the radius of that particular capillary tube. So next is the relation between mass of liquid and a radius of capillary tube. So according to the above formula, H equals to 2t cos theta divided by rho G A. We can write density equals to mass divided by volume. Volume, since this particular tube is cylindrical in shape, so volume will be equals to pi r square times h. So just replace this density by this term. So you will get 2t cos theta divided by mass upon volume. So it will move to numerator pi a square h times gravity into A is equals to h. So this A and this A will cancel out. This h and this h will cancel out. So move this m to left side. So m will be equals to 2t cos theta times pi into A divided by g. These all are constant, so m is proportional to A. So the more the radius of capillary tube, the more mass of liquid will rise or fall due to its interaction. Is it clear? Asma, any doubt? Samaira?
Sir, can you repeat?
Okay. Initially, we had h equals to 2t cos theta by rho ga. So depending upon theta, we can define whether it will rise or fall. Now we have to calculate in terms of mass. So density is mass divided by volume. And since we are discussing in capillary tube, which will be cylindrical in shape, so the volume of liquid level or a rise up level of liquid will be pi r squared times h. So just replace this density by this much amount in this formula. So density is mass divided by volume. So it will move to numerator. A and A will cancel out. H and H will cancel out. So move this mass to left side. So you're left with just A only. 2t cos theta pi g, these all are constant. So m is directly proportional to A. It means the more the radius of capillary tube, it means it will contain more mass of liquid. Is it clear?
Yes, sir.
Shravya, any doubt?
No, sir.
Okay. Now, there will be some question related to these two terms, height related to A and mass related to A. Just write it down to this part.
Done, sir.
Done, sir.
Just 1 minute. You all have written till this? Aisha?
Then, sir.
Okay. A capillary tube having a radius A in which 5-gram liquid H. Find level of liquid and mass if radius of tube becomes a by 2. Just relate how radius is related to level of liquid or height of liquid, and how radius is related to mass of liquid. Samira, any problem while solving?
So can you explain how to do?
We have to define two different terms. First is height, and second is mass related to radius. So in every part, I had just explained you two different terms. H is equals to 2t cos theta divided by rho g a. Now just compare how height is related with radius of this particular capital tube. Is it directly proportional or inversely proportional? Samira?
Inversely proportional.
So if you decrease radius of capillary tube, so height is inversely proportional to this. So it will get increased by same factor. Or you may put like h dash equals to 2t cos theta divided by rho g a by 2. And then divide these two terms. So the rest of the whole term will get cancelled out. So this 2 will move to numerator. Now, in numerator, you'll get 1 divide by, this is 1 by 2, so this will move to this part only. So this will be 2. Now just cross multiplication. So h dash will be equals to 2 times of h. Is it clear?
Yes, sir.
Samira,
Yes, sir.
in next part, in relation with mass, mass equals to 2t cos theta times pi divided by gravity times A. So initially, mass of liquid is 5 gram. So it will be 5 equals to this much constant times A. Now we have to calculate mass of liquid if radius becomes half of its initial. So just divide these two terms. this constant part and this constant part will get cancelled out. A and A will cancel out. So this 2 will move to numerator. So you'll get 5 divided by m equals to 2, or m equals to 2 by 5, 5 by 2. 2.5 gram. Is it clear?
Yes, sir.
Shravya, any doubt?
No, sir.
Arslan, is it clear till this part? Okay. You all have written?
Yes, sir.
Asma? Safan? Done?
Done, sir.
Okay. So this is all about hydrostatic part or liquid at rest. Now move on to hydrodynamics or liquid in motion. In hydrodynamics part, first we define Newton's law of viscosity. According to Newton, liquid in a particular medium, let's say tube in a particular channel or anything, it always flows in layer by layer structure. So let's say one of the layer of liquid is this, having area of cross section A. Adjacent to it, another layer. So each consecutive layer opposes its neighboring layer by force, which is called viscous force. So due to this opposition, these two different layers will move with different velocity. So let's say velocity of this particular layer is V. So this layer will move with some greater velocity as V plus dV. As this top layer will be opposing this bottom layer by an opposing force in backward direction. This force is called viscous force. So according to Newton's law of viscosity, the viscous force between any two adjacent layers of liquid will be directly proportional to area of liquid film, that is area of this entire liquid region, and second, directly proportional to velocity gradient. Now let me define you what do you mean by gradient. In physics, we define two different terms. First is rate, change of any quantity with respect to time. Rate of change of velocity, rate of change of displacement, rate of change of linear momentum. So these quantities are changing with respect to time. So we can define rate. Similarly, there will be another reference of changing with respect to length. Change of quantity or any physical quantity with respect to length. It is called gradient. Now in this part, velocity of each layer is different. So there is change in velocity of each layer having some width dy. So we can define change in velocity with respect to change in width or between layer of liquid. Is it clear?
Yes, sir.
Yes.
So according to Newton's law of viscosity, liquid flows in layer by layer structure in which each consecutive layer opposes its neighboring by an opposing force called viscous force. Now, this viscous force will depend upon two factors. First is area of liquid film, and second is velocity gradient. This force is directly proportional to the area of liquid and also to the velocity gradient. Safan, is it clear? So according to this relation, we can write viscous force is depending upon two factors. First is area of liquid and second is velocity gradient. So F directly proportional to A, F directly proportional to velocity gradient, that is change in velocity with respect to change in length. Now, if we combine these two equations, F proportional to A dV by dy. Now, replace this proportionality sign by any constant term. So you'll get F equals to minus eta A dV by dy. This minus sign indicates that this force is opposing in nature. This constant of proportionality is Greek alphabet eta, which is also called coefficient of viscosity. So its SI unit is Pascal second. CGS unit, poise. So there is relation 1 Pascal second is 10 poise. Eta will be dependent on temperature as inversely proportional, just as surface tension. Is it clear till this part?
Yes, sir.
Samaira, any doubt?
No, sir.
Okay, just write it down.
Done, sir.
Done, sir.
Safan, you have written? Aisha?
Yes, sir.
Okay. Asma, done? Now, we can rearrange this particular relation to find some different property of viscosity. F equals to minus of eta A dV by dy. Suppose this layer of liquid is going along this direction with some velocity v. So opposing force on this adjacent layer will be tangentially to it. So this force will be tangential to the surface area. So we can rearrange this equation as eta equals to minus F divided by A whole divided by dV by dy. This force per unit area is nothing but this force is tangential to the surface per unit area. So we can write it as shear stress. What we had learned in previous chapter, that is mechanical properties of solids. And in this denominator part, dV by dy may be written as dx over dt times dy. This dx is along horizontal shift and this is vertical length. So there is change in length with respect to original length. So this particular ratio will be also termed as strain or shear strain divided by time taken. So any quantity is changing with respect to time is termed as rate. So we can write this particular expression as strain rate. Is it clear?
Yes, sir.
So this eta is also equals to ratio of shear stress to the strain rate. So Myra, any doubt?
No, sir.
Just write it down. You all have written?
Yes, sir.
Suppose there is a horizontal surface and a pulley is attached to it. A block is connected with a string, is hung by another block having mass m. There is a liquid just below it having width 0.1 mm if this block has to move with some constant velocity of 10 centimeter per second, eta of this particular liquid is 0.05. Find mass of block to move this system at constant velocity. Let's say area of liquid film is just use the above formula and try to find. Let me give you some hint how you'll approach this problem. Suppose we have a block which must be acted by gravity in downward direction. So there will be a force mg, which will be responsible to keep this particular block to move with constant velocity. So this force will be equivalent to amount of viscous force experienced by this layer of liquid. So put this F as mg. Now we have eta, area of cross section of this liquid film, velocity, and width. Just put all the values and try to find the value of m. Take gravity to be 10 meter per second square.
So here for velocity, should we convert centimeter to meter?
Yeah,
Okay, sir.
all quantities should be in SI unit.
Yes, sir.
Samira, you got any answer?
Sir, I'm done.
Let me solve. Mass equals to eta A dV by dy times gravity. Eta is 0.05. Area of liquid film is 1 mm square. So we can write 1 × 10⁻⁻⁶. Velocity is 10 centimeter. So just multiply it by 10⁻⁻² to convert it to meter. Divide by gravity, which is 10. And dy is 0.1 mm. So it will be 0.1 × 10⁻⁻3. Now this term will cancel out. If we replace this negative or decimal, you'll get 10⁻⁻², and replacing this decimal, 10⁻⁻1. So -6, -2, -2, so it will be -10. This two term, it will be -4. So this term will cancel out. So you'll get 5 × 10⁻⁻6 in terms of kg. Or you may write it as 5 micro 5 milligram. Is it clear?
Yes, sir.
Asma, any doubt? Okay. Now, on the basis of this concept of viscosity, we can define flow of liquid in different tube. So next is types of flow of liquid. We mainly have 3 different types of flow. First, if there is a tube having varying cross section, area of cross section at this point is A1, area of cross section at this point is A2. If each layer of liquid moves with same velocity at this cross section area A1 as V1, and similarly at this point, each layer is moving with same velocity V2. This will be possible only if there is no viscosity between layer of liquid. So we can say this liquid should be non-viscous. Next, it should be non or incompressible, and it should be irrotational. So this particular flow of liquid should be ideal, so we can call it as streamline or ideal flow. For this, there should be some limiting condition. First is liquid should be non-viscous, incompressible, and irrotational. Next, suppose there is a tube in which centralmost layer will move with maximum velocity as it will experience least viscous force, and all of its adjacent layer will be experiencing opposition force due to this consecutive layer, as well as from the side wall also. Similarly, along this direction, so that centralmost layer will move with highest velocity and the edges layer will move with slowest velocity or least velocity. So this type of flow is called laminar flow. Is it clear?
Yes, sir.
Next is suppose there is a tube in which each layer having some irregular velocity. Due to some irregularity in velocity or due to encountering with some particle in its path. Suppose if there is some particle in its path at this point, so these 2 layers of liquid on striking it will get stopped. Next adjacent to it will move forward and it will experience some curling or eddy formation at this point. This type of flow in which there is some formation of eddies is called turbulent flow.
So could you again explain turbulent flow?
Okay. Suppose there is a tube in which liquid is flowing, and if there is particle in between path of any different layer. So due to this particle, which is in path of these two layers, so it may strike this object and get stopped there. Next adjacent layer will move forward, and at this point or at this location, it may have some vacant space since there is particle just behind it. So it may create some vacant space at this point since these two layers are just striking at this point and get stopped. So there will be some vacant space at this point. So this two layer will move forward and get spiraled at this point. This spiraling behavior is called eddies formation. So the flow of liquid in which there is some formation of eddies is called turbulent flow.
Clear, sir.
Okay. Samira, any doubt?
No, sir.
So we mainly have these three different types of flow of liquid. So we have to assign how to define when or at what condition these three different flow of liquid would be. So let's write it down to this part.
Done, sir.
Done, sir.
Okay. So to define different types of flow, we can define a number that is called Reynolds number. It simply defines a specific numerical value on the basis of which we can distinguish different flow of liquid at different conditions. To define it, let's suppose there is a tube having diameter d in which a liquid with some critical velocity is flowing, so that or for which flow of liquid is streamlined. So velocity of liquid in this particular flow is critical. Density of liquid is rho and coefficient of viscosity is eta. So first, what do you mean by critical velocity? The velocity of layer of liquid for which flow will be streamlined. Now, this critical velocity may depend upon three different factors: density of liquid, coefficient of viscosity, and diameter of tube. If critical velocity depends upon diameter of tube, that is d, density of liquid, that is rho, and coefficient of viscosity, eta. So we have to define or derive a formula of this critical velocity depending upon these three different factors. We had learned in chapter 2, dimensional analysis, there was application of dimensional analysis, how to deduce relationship between different physical quantity. So first, we have to define which quantity is depending on. So we have critical velocity, which is depending upon three different factors. First is diameter of tube, second is density of liquid, and third is coefficient of viscosity. So on the basis of its dependency, we can write its formula as critical velocity equals to some proportionality constant and its depending factor diameter raised to x, density raised to y, and coefficient of viscosity eta raised to z. So this will be some empirical relation between their dependency. Is it clear?
Yes, sir.
Yes, sir.
Asma, Riaz, any doubt? Aisha, any doubt?
No, sir.
Okay. Now, according to the rule of dimensional analysis, just write the dimension of each term on each side. So we have velocity in left side, which having dimension as m0, L1, t raised to -1. K, any dimensional as constant or proportionality, so just neglect it. D, diameter is nothing but length. So we can write L raised to x. Density is mass by volume raised to y, and coefficient of viscosity is ml minus 1 t minus 1 raised to z. Now, we can write m raised to y at this point and m raised to z at this point. So it will be y plus z. L raised to x minus 3y and minus z. And last, t raised to minus z. So I have just expand this expression and define the same base to one side. Now we have an equation in which three different terms, mass, length, and time. So just compare the exponent of each part to the same term in both sides, then you'll get the value of x, y, and z. Try to solve. Just compare the exponent of each part. You'll get three different equations. Just solve them to find the value of x, y, z. Good, Shravya. So Myra, just send your answer. Good. Good. Good, Samara. Good, Shravya. Asma, just send your answer.
Yes, sir. Sending.
Okay, so on comparing the exponent on both sides, we have m raised to 0 in left side. So y plus z equals to 0 as first equation. Second, x minus 3y minus z equals to 1. And third, minus z equals to minus 1. So minus minus will cancel out. So you get z equals to 1. Put this term in first part, y plus 1 equals to 0. So y will be minus 1. And put these two values in this middle part, x minus 3, y is minus 1, minus z, which is 1, equals to 1. So x minus minus plus minus 1 equals to 1. So 3 minus 1, 2. On moving to the other side will be minus 2 plus 1. So you'll get just minus 1. Asma, you got this answer?
Yes, sir.
Good. Now, if you put all these values in the above equation and replace R or K constant by RE, so velocity equals to RE d raised to x minus 1, rho to y minus 1, and eta raised to z plus 1. So it will be RE times eta divided by rho d. So just rearrange this equation to find RE. So RE will be equals to rho Vd divided by eta. So this is called Reynolds number. So it will be a constant value or dimensionless quantity, just number, on the basis of which we can define types of flow of liquid at different extent. So it simply defines the type of flow of liquid. Suppose if R is less than 1000, so it will be streamlined. If RA is greater than 1000 but less than 2000, so it will be laminar. Third, RE is less than 3000, greater than 2000, so it will be unstable between laminar and turbulent. And last, if Reynolds number is greater than 3000, so it will be perfectly turbulent. Samira, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Aisha, you have written?
Done, sir.
Yes, sir.
Asma, done? Just try to solve. If water is flowing in a tube of radius 10 centimeter, if eta is 0.05, find type of flow. Take rho equals to 10 to the power 3 kg per meter cube and velocity of liquid (20 centimeter per second). Just put all the values and try to find Reynolds number. Asma, you got any answer? Samara, you got any answer?
Sir, I'm doing.
Density is 10 to the power 3. Velocity is 20 centimeter per second. So just multiply it by 10 to the power minus 2. Diameter is, we have radius as 10 centimeter. So diameter will be 20 centimeter. Whole divided by eta, which is 0.05. So move this decimal, so you get 10 to the power 2. This term and this term will cancel out. 5 and 4 times will be 20. And just simplify it. So 4 into 2, 80 into 10 to the power minus 2 plus 3. So it will be just 1. So it will be 800. Shravya, just check your calculation. Okay. And this 800 is less than 1000. So you can say it will be streamline. Asma, is it clear?
Yes, sir.
Okay. Samara, any doubt?
No, sir.
Now there will be some other relation to find Reynolds number in some other way also. There's a quantity which is called rate of flow of liquid. Denoted by Q equals to volume of liquid flowing divided by time taken. We can write volume as area times length divided by time taken. Length per unit time is nothing but velocity. So it will be A times V. Now in this part, tube having diameter D, so we can write area as pi diameter square by 4 times V. So just rearrange this equation to find velocity. So it will be 4 times Q divided by pi D squared. Now, if you put this particular value in Reynolds number, you will get rho V D by eta. Put V as 4Q times D divided by pi D squared times eta. So D and D will cancel out. So you're left with 4 times Q into rho divided by pi D eta. So this is some other expression of finding Reynolds number. Is it clear? Shravya,
Yes,
any
sir.
doubt? Okay.
No, sir.
We can also write Reynolds number in some other term also, as Reynolds number equals to rho V D by eta. We can write rho, that is density, equals to mass divided by volume. So it will be mass divided by volume times velocity diameter eta. Mass is equals to, or keep mass as it is, velocity, just write in terms of acceleration using first equation of motion. Take initial velocity to be 0. So velocity will be equals to acceleration into time into diameter divided by volume. We can write volume as area into length times eta. So if you rearrange this equation, you will get mass times acceleration in numerator divided by eta A times x divided by d into t. So this term is velocity divided by length. So it will be velocity or velocity gradient into A times eta. So this entire term will be viscous force. And this numerator is mass times acceleration, which will be termed as inertial force. So we can write Reynolds number is also equals to or ratio of inertial force to the viscous force. Is it clear?
Yes,
Asma?
sir. Yes, sir. It's clear.
Okay, just write it down.
Done, sir.
Done, sir.
Asma, you have written?
Yes, sir. I've written.
Okay. So this is all about Reynolds number and defining types of flow of liquid. So according to Newton's law of viscosity, it simply defines viscous force acting between layer of liquid or each layer opposite its neighboring layer. Now, if you have to calculate amount of viscous force experienced by a body when it is projected in a viscous medium, so it is defined by another term that is called Stokes Law. So it defines viscous force experienced by a body projected in viscous medium may depend upon some factor, depends upon coefficient of viscosity, that is eta, radius of body, r, and velocity of projection, v. Shravya, any doubt?
No, sir.
So just consider there is a medium or viscous medium in which a body having radius r is projected at velocity v. So there will be an opposing force on it, which is called viscous force. So according to this relation, we can define this viscous force has dependence over coefficient of viscosity, radius of body, and velocity. So according to this dependency, we can write F viscous equals to some proportionality constant K, dependency over eta raised to x, r raised to y, and velocity raised to z. So this will be your empirical relation between these quantity or their dependency. Now put the dimension on both sides and solve them to find the value of x, y, and z. So let me define you dimension of each part. In left hand side, we have force having dimension mlt raised to -2. K is proportionality constant. Eta, it will be ml-1 t-1 raised to x. R, radius, it will be length, and velocity lt-1 raised to z. So on rearranging, you will get m raised to x, l raised to -x, plus y, and plus z, and t raised to -x minus z. Just compare the exponent on each side to find the value of x, y, and z. Try to solve. Shravya, just check your calculation. We have m raised to 1 in left hand side. Good. Good, Samaya. Good, Shravya. So on comparing the exponent on both sides, we have m raised to x and m raised to 1. So x will be equals to 1. Minus x plus y plus z will be equals to 1. Minus x minus z will be -2. So put the value of x to be 1. So it will be -1 minus z equals to -2, or z equals to just +1. Now move these two values, or put these two values in this middle equation. -1 plus y plus 1 equals to 1. So y will be equals to just +1. Asma, you got this?
Yes, I got this.
Okay. Now, put K proportionality constant to be 6 pi. So you'll get viscous force equals to 6 pi eta r times v. Now this entire term 6 pi eta r will be constant for that particular object and it's influencing surrounding liquid. So this force will mainly depend upon this velocity. So this particular quantity, 6 pi eta r, will be responsible for opposing that body. So it is also termed as damping factor, the factor which is responsible for opposition to that body. So we can call it as damping factor. So due to which it may be represented by B or sometimes gamma. So this above equation will be minus of gamma times V or minus of B times V. Minus is due to its opposing behavior. Is it clear?
Yes, sir.
Asma, any doubt?
I
No,
lost
sir, no
7
doubt.
times.
Okay.